Hello coders, in this video we will solve next question from our Leetcode 75 list. And yeah, let me take you to the screen first. And we are solving Leetcode 75 list, and yeah, we solved several questions from that, and today we will see the next question, this one. We have solved this whole questions till here. Graph, we completed graph DFS, and today we will solve the first question from graph BFS, which is the nearest exit from entrance in maze. So yeah, let's see what the question is. So basically what question says is, you have given coordinates, which is your entrance, and you need to get out of that grid. And the way we get out of that grid is, or we can say maze, is if you go to the edges. Basically edges means what, like you are at top upper row, or top down row, or leftmost row, sorry, leftmost column, or the rightmost column. If you are at that, then you can easily get out of that. Like you have a way to get out of that mess. And if you are not in between these, the two rows and two columns, then you have to move towards those things, like towards those rows and column. Basically it means that. And while doing this, we need to find in how many minimum steps we can get out of that maze, that we need to find. And the maze contains a space, we can say empty space, and wall. And empty space represented by dot, and wall is represented by plus sign. If there is a plus sign, like let's imagine you are at a cell, and you can go up, down, left, right. On this four side, if four are walls, then you can't get anywhere from there. It's basically you are trapped there. If any one of it is dot, then you can escape from that way. Like you can take that way and you can go to the next cell. This basically means that. And if you ended up in just walls in everywhere, then you have to return -1, that there is no path basically to get out of that maze. So yeah, how we can solve it? uh, as we saw, it's from BFS graph. We can use BFS here. And why BFS works here? Because let's say you are at, and also one thing that they have said, ki your entrance cells can't be counted as exit cell. So basically what they say, ki let's say ki you entered from a topmost row, or downmost row, or leftmost column, or down rightmost column. Your entrance coordinate contains such coordinates. Then that specific entrance coordinate can't be counted as your exit. That is entrance point, and you have to get out of another point. That's what they said. Okay, so how we can use BFS here? Uh, and how we can say ki I will use BFS here? That the one thing that they are saying ki we need to get out of the grid. Okay, and we have given entrance points. What are the ways that to move from that cell we can take, or and we have. So there are only four ways that we have, that either we can go down, either we can go top, either we can go right, either we can go left. At a time we can go at a point. We'll do backtrack, like we'll come back and we will start again. But like for that we need to take back, then again we need to start. That these things specify that we will do DFS, but like backtracking happens in DFS. But in BFS, like how we can say ki we'll use BFS? So one thing that we'll go, like at the time we will consider, we are going at at all sides, that at four side, if I can go four side, like I have four dots, like down, up, and left, right, then I can go four side, right? I'll take all four coordinates, okay, at a time. It's basically this is my first level. At first level I can go at these four coordinates, and this will be take time 1, right? In time 1 I can go either upper, either down, either likewise. Whatever the step I will take, I will say ki I took all the step in first level. Like I'm just saying ki how many possibilities are there for time, like it basically we need to return minimum number of steps. So if I take one step, how many number of ways, like how many coordinates I can visit in one step, that I will take. In next step I will take all the coordinates which I can visit in two steps. So basically it is indicating that we are going level wise, and this says ki we need to use BFS. Okay, so that's the into like that's the process, like that we not the process, intuition we can say ki that we are getting ki I'm going stepwise, and in one step how many cells I can visit, then two step how many cells I can visit, that I'm taking, and this gives us the intuition of use BFS. So we'll use BFS and we will write code and we'll return the answer. Let's take me to the screen again, and yeah, 1 minute. What's happening today? 1 minute. I'll take you in 1 second. So yeah, now this and here. Yeah. So here we will solve this question. So basically I say key will use BFS. Okay. For the BFS we need Q. So we'll take Q. This will contain a vector of pairs of int in. Why I am taking pair? Cause I will have coordinates which in the form of pair xy. So I'm saying here I will have I can say just pair. I don't say vector, cause I will take all the coordinates which I am visiting in that step in the queue, and then I will take size, and till completing that size I will take next coordinates, and I will push that coordinates in the queue. Okay, that I will do. So the structure will be queue of pair int, and this is the basically a queue. So I am taking just queue, and what I will do keep first that I am visiting, that the entrance one. So I will push q dot push entrance 0. Entrance 0 will basically represent x, and entrance 1 will represent the next y. Entrance 0 and entrance 1. So yeah, we started, and then what we will do, we need to take step count. So I will say ki I'm at 0. I didn't took any step right now, so I'll say step is equal to 0, and I need to go up, down, left, right kind of directions, right? So for that I will take one, like I will take two vectors, x direction and y direction, and x of x direction and the y of y direction. The vectors y direction. Basically, these it will contain numbers which I need to add to go up, to go down, to go left, and to go right. So if I want to go up, then I need to add to the x coordinate, right? So it's like this only. This dimensions like this. So to add a row, basically to go up, I need to add 1, and for y means here column, so I don't need to add anything. If I need to go to the right. Then for x, we are not changing the row, so we'll say 0. We'll change the column, which is 1. To go down, I need to go up. Sorry, basically to go up, I need to reduce one row, and yeah, that's what this means. Then go right, I don't need to change row. To go down, we need to change row by 1 and column by 0. And if I need to go left, then I need to change, I don't need to change row, I need to change column by -1. By basically we can say I'm just going behind from that side, like from that cell. Okay, yeah. So we prepare this x direction, y direction to go 4 direction from that cell. So while q isn't empty, what I will do, not empty, I will say q take first q size, I will say q dot size, and till that size is basically mean ki in that much step I can visit this much cells. So yeah, in one step, how many cells I can visit, like how many, not how many, but I can say I'm stepping now, so I will say ki steps plus plus, and for t I equals to 0, I less than qs, that q dot size, and I plus plus. I will take out that cell. I will say it's auto cell is equals to q dot front and q dot pop. As I visited it, like what I will do here, ki when I visit that cell, at that time only I will say ki as I visited it, I will say ki I will not come here again. So I will mark it as I'm going level wise, right? I will not come like a DFS to backtrack. So I am leaving it, and I'll say ki this is wall. I don't want to come here again. So I will say ki this is wall for me. So I will change this maze of entrance 0 and entrance 1. 0 and entrance 1 is wall for me now. So I will say it is wall for me. For that, what I need to do? Wall sign is +1, plus, so plus. I will take out the cell. What I will do here, ki I'll check ki if this cell, okay, if I'm checking it, then I don't need to do steps plus plus here, because I can say here ki in this step I'm here, like in 0th step I am at this cell. So step was the 0. So yeah. So you confirm now, and I also confirm ki steps plus plus should be after visiting all the cells in that queue. Okay. At 0th step, I am at this cell, and what I will say ki let's take x coordinate of that cell. X coordinate is cell dot 0, cell dot first, and y coordinate is cell dot second. Yeah. And what I will do ki if this x equals to n, okay, n and m I didn't took, so I need to take how many rows are there in maze. I will say ki my n is equals to maze dot size, and m means number of columns is maze 0 dot size. And then what I will do, I will check if my x equals to 0, or I am at upper row, or my x equals to n minus 1, or I am at down row, or y is equals to n minus, sorry, y is equals to 0, it means I am at leftmost cell, like I am leftmost side, or y is equals to m minus 1, but it means I am at rightmost side. If it is, also check ki x shouldn't be equal to entrance 0 and y shouldn't be equal to entrance 1. That both conditions shouldn't be like it means we are at the same cell, right? From where we are entered, we again there. So y is equals to, it shouldn't, like y, x and y shouldn't be equal to entrance. So yeah, this shouldn't happen. Or we can say x equal to, and we will take it out like not. If it is, if it is, then it will return 1 and we will do it 0. And is it right? Or I can take it at inside it. I will take inside. Okay. If it is, then I will go inside this and I will say if control V. If it is, then just I don't need to do anything. And else what I will do, else it means I am at edge and I need to return steps. Yeah. And otherwise, if I'm not at edge, then what I will do, I'm at its cell, I need to go in 4 direction, that in that steps, right? So I will go in 4 direction. For that, what I will do here, I'll run one for loop. I'm doing okay, and this one is for this, and this is one for this. Okay, what I will do, I will run one for loop. This one for plus, and I will take new coordinate, which is int new x equals to previous whatever the x was there, and x direction 0, and int ny is equals to y, new y, basically y directions at not 0, it's I at ith direction. Okay, first I will check if it is valid or not. How I will do it? If x new x, my new x is less than 0, it means it's invalid, right? Or my new x is equal to n, it means it's also invalid because I have n minus 1. Like, though I have n rows, though that numbered as n, last numbered is n minus 1 row. So if nx is equal to nn, then also it's invalid. Or my ny equals to sorry, ny is less than 0. Basically it means if my ny is negative now, or my ny equals to m, then I need to do continue because it is my invalid cell. Take next direction, like whatever the next direction it is, take that cell. This is going out of cell, or yeah, this is not the right cell for me, it is invalid cell. Okay, so if it passes this if block, it will come down. And what I will do here, okay, now I got new cell. I will check if it is wall or it is space. If it is space, it is dot. If it is wall, it is plus sign. So what I will do, it is a why it is showing a string. Okay, it is char only. So yeah, I will say math of nx ny equal to plus. It means it is a wall. I should not go there. So in that case also I will do continue. And then if it is the space, then I will come here. And now what I will do, I will enter that, I will push that cells in the queue. So I will say q dot push those cells new x and new y. And what I have to do, I have pushed it and I don't want to go there again by visiting through any of cell. So I will say maze of that new x and new y is equal to plus. Like basically for me it is wall now, because I took it first. I took it and I don't want to go there again. So okay, so I will do plus sign here. Maze equals to this. Like basically I am creating a wall there. I took that space and I'm thinking that cell is for me, it is wall. Okay, I will do this, and then what we will do? Yeah, if I don't return any steps, like here I wrote the steps function. What does it was mean? I'm at edge, and I'm not the entrance cell. It means ki I can go out from there. So I'm returning the steps. It means ki in those steps I found the way to exist. So yeah, if I don't return anything, it means ki I don't find exit and I will return -1. Let's run it. So let's submit it. Time limit exceed. Oh, why? We didn't pop out, or if it is less than, then we are visiting it and also. Okay, nice. So the mistake is this one, which was here. We had this equal to sign. That's why we were getting time limit exceed error. That I will show you. This was the one that we saw. Here we took equal to sign. Basically, we were comparing if there is equal to sign or not. But we had to, whenever we need to push that cell inside the queue, we had to keep that, like we had to say keep that cell is wall for me. So I will say it is +1. That not this, like this. Okay. So yeah, I will submit it, and now this got accepted. And yeah, so how much time, like for the time complexity for this, for the time complexity, it will be big of n cross n, which is big of n square. And space complexity also same, because we have q and we are taking those cells. So yeah, this was all about this video, and we will meet in next video. Till then, bye bye.